Sorry for ending the video and starting the problem in the middle there, but I had a typo in my tree which messed everything up, and the software I'm using won't let me redo it, and I don't want to redo what part of the video I did before, but I think I've fixed it. I accidentally swapped red and white on part of this one. But anyway, we have an example here. A bag contains 4 red balls, 5 blue balls, and 6 white balls. 2 balls are drawn one after the other without replacement. Draw a tree representing the experiment and then find a bunch of different probabilities. But we'll do the tree first. Okay, so I took the time to animate this one in here. So you're going to draw one ball. There's 3 possible colors. It could be red, blue, or white. And looking at the numbers there, the probability that it's red would be 4 out of 15. If you add up 4, 5, and 6, there's 15 balls total. So 4 out of 15 are red. 5 out of 15 are blue, 6 out of 15 are white. And then this tree becomes pretty big there on the second step, because out of each of the 3 colors, you have branches going to each of the 3 colors. So red, blue, white, red, blue, white, red, blue, white. Each of these probabilities would now be conditional probabilities. There's only going to be 14 balls left, so all the denominators will be 14, and we have to think about the color of the first ball to figure out how many are left of the particular colors. So if you look at the first one, the one at the top here, the R, here we're going RR, so this is the conditional probability that the second ball is red given that the first ball is red. That would be 3 out of 14. If we've taken one of the red balls out, there's only 3 left, and there's 14 balls left. Okay. Blue would still be 5, but out of 14. And then white would be 6 out of 14. So the numerators stayed the same because you took a red ball out if you're coming off of red here. But the denominators all dropped to 14. But if you went red, red, numerator and denominator dropped by 1. So that type of thing happens on each of the branches here, depending on the colors. If we look at blue and then red, so our denominator would be 14, and there would still be 4 red balls. For blue, blue, the numerator would drop to 4 out of 14, and then white would be 6 out of 14. And then, let's see which order I animated them in here. If we do white, white, it would be 5 out of 14. If we took a white ball out, it went from 6 down to 5 out of 14. And then blue would be 5 out of 14, and red would be 4 out of 14. So, pretty big tree, but there's all the numbers, and it definitely helps me do all of the rest of the parts much more quickly than redoing the numbers every time. Okay? So here we go. What's the probability that we get a blue on the first and a white on the second? So now we can just follow the branches of the tree. Okay? Get a blue on the white, or a blue on the first, a white on the second. So we'd have 5 out of 15 times 6 out of 14 would be our probability, which is 30 out of 210, or 0.1429. Okay, part B, what's the probability red on both? So that would be red, red, if we follow the branches. So 4 out of 15 times 3 out of 14, which is 12 out of 210, or 0.0571. And then we start getting a little more complicated. Part C, the probability of drawing a blue and a white. Okay? So there the order doesn't matter. It could be blue, white, or white, blue. Okay? So we're actually combining a couple of rules here. We're going to add 2 of them where we multiply the branches. Okay? So technically we have the probability that it's blue, white, or white, blue, where we're looking at the order. Blue, white, white, blue, each of those we would multiply the branches, and then it's an or, we would add them together. Okay? So we get 5 out of 15 times 6 out of 14 plus 6 out of 15 times 5 out of 14. So we trace our possible branches, we multiply along the branches, and we add the separate ones up together. And you wind up with about 29%, 2857. And then one more, what's the probability that the second ball is red? So in that case, it doesn't matter what happens on the first, so there's 3 ways that can happen. It could be red, red, blue, red, or white, red. And so we're going to have 6 numbers involved, 3 multiplications. So it's the probability that it's red, red, or white, red, or blue, red. Again, the particular order there doesn't matter as long as we've got all the combinations. So red, red would be 4 out of 15 times 3 out of 14. White, red would be 6 out of 15 times 4 out of 14. And then blue, red, 5 out of 15 times 4 out of 14. Compute all that very carefully. You get 56 out of 210, or 0.2667. So that's how we can use a tree to help us do these probabilities. We're just using, in this case, the addition and multiplication rules, the rules for and or, because it's probability that it's red and red, or white and red, or blue and red. So it's a combination of our rules.